Solve linear systems by addition. Well, thus far we've been looking at linear systems and we've solved them by graphing and we've solved them by substitution. In this video, our objective is we want to solve a system of linear equations. Oh, that should be the word equations. Sorry about that. Solve a system of linear equations in two variables by addition. Well, what do we know? We know what a linear system is. It's also called a system of linear equations. A linear system is two or more linear equations working together. And we've been working with linear systems that involve two variables. And here's an example: x plus y equals 7 and x minus y equals -1. All right, so the general idea here is we want to convert the system of two equations in two unknowns into one equation in one unknown by adding the equations. We did this by substituting. Now I want to do it by adding. And let's start off with a simpler example that kind of already has this set up for us. So here in example 1, we want to solve this system: 3x minus 4y equals 11, and negative 3x plus 2y equals -7. And I'm going to write this system down here without the curly bracket. So 3x minus 4y equals 11, and negative 3x plus 2y equals -7. Now here's the idea. The idea is that you can add the same thing to both sides of an equation. In algebra, if I can add 1 to the left and I can add 1 to the right, and I've not changed the fact that it's an equation. Well, if this side equals this side, then these two things are the same thing. And so I can add them to both sides of the equation. So I can basically add them. And notice what happens here when I add up my x's. 3x plus -3x, I get no x's. So that is a big old 0. I add up the y's. Negative 4y and 2y is -2y. And whoops, I forgot, that's an 11. I'll bet you all caught that. That's an 11. 11 plus -7 is not -4. It's +4. There we go. And then, of course, now I have one equation in one unknown. And that was the goal. I want to get the two equations in two unknowns down to one equation and one unknown. I've done that, and this is easy to solve algebraically. And then we can say, oh, if y equals -2, I can put -2 back into the top equation or the bottom equation in this case, and I can solve it for x. Okay, so this is a simplified version of how to solve them with addition. And here's the key is right here. The key is having one of the variables with opposite coefficients. So I come down a little bit and I got a little arrow here, a big arrow I should say. The key to the addition method is to obtain for one of the variables, and this was already obtained for the x variable, coefficients that differ only in sign. The coefficients are both 3, and they only differ in their sign. This is a +3, and this is a -3. And that's the key to making this work. Let's take a look at some little more complicated examples, and you'll see as we work through a couple of examples how this works. It's kind of a neat little trick. I guess I called it. It's a neat use of algebra. How about that? It's not really a trick. Okay, so how do we solve a linear system by addition? If necessary, we want both of our equations to be in the general or standard form ax plus by equals c. So you might have to make sure that's the case. Number 2, again, if necessary, because this was not necessary in example 1. if necessary, multiply either equation or both equations by appropriate non-zero numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. In other words, either the x coefficients or the y coefficients differ only in sign. Okay? And then step 3, let's add them up like we did in example 1. We will then have a sum that is one equation and one unknown. That's easy to solve. And then we can back substitute. And then we're obviously going to check our solution in our proposed solution in both of our original equations. Let's take a look and let's follow this with a little more complicated example right here. I guess I used example 1 twice. This should be example 2. Look at that. Okay, so we'll take a couple mistakes already here on my end. Example 2. Solve using the addition method. And my two equations are 3x plus 2y equals 48. And I'll call that my equation 1. And 9x minus 8y is equal to negative 24. And we'll call that equation 2. And I'm going to write them. So step 1, if necessary, make sure they're both in general or standard form, and they are. So step 1 is already taken care of. Step 2, I'm going to write them down again. So 3x plus 2y equals positive 48. And let's hope I'm not making too many mistakes. 9x minus 8y equals negative 24. So step 2, multiply either equation or both equations by an appropriate non-zero number so that our x's or our y's differ only in sign. If I look here, and I have two choices. I can multiply equation 1 by negative 3, and that will be a negative 9 here and a positive 9 here. Or I can multiply equation 1 by positive 4, because that will result in a positive 8 and a negative 8 here. And that would be two equations that differ, the coefficients differ only in sign. You can go either way. Okay, I'm not a fan of working with negatives. I try to work with negatives as little as I can. So I'm going to choose this. I'm going to choose to multiply the top equation by positive 4, because that way I will have a positive 8y, and when I add it to a negative 8y, that will be a sum of 0. In the second equation, I'm not going to make any changes at all, so no change. I already have, by multiplying the top equation by 4, I already have my opposite coefficients. So what does that give me? Well, the top equation by times 4 is 12x plus 8y. 48 times 4 is 192. I did not do that in my head. I previously did it with the calculator. just so you know, I'm not that good. No change to equation number 2. It is 9x minus 8y equals negative 24. So this is step number 2 right here. Okay, as necessary, multiply either equation or both by an appropriate non-zero. I did the top equation by 4 so that I get opposite coefficients. I get a sum of 0 when I go to add. Okay, let's add them. Okay, so let's add. Well, those become a 0. So I'm adding 12x and 9x is 21x, and 192 plus negative 24 is 168. This is step 3. I add them up. Step 4, solve it. Well, that's easy. Divide by 21. Divide by 21. And x is equal to, I've already used my calculator, x is equal to 8. And there you go with step number 4. Okay, so I think x is equal to 8. Let me slide up a little bit before I get myself too far down. Let's put now, I think x is 8. Now I want to figure out what y is. So back substitute step 5, x equals 8 into either of the original equations. Pick one and solve for the other variable. So step 5, I'm going to choose equation number 1. And equation number 1 is 3x plus 2y equals 48. And I'm going to back substitute. I think that x is 8. I'll put 8 in for x. All right, and this gives me one equation in one unknown. I can solve this. Let's see, this is 24. Subtract 24 from both sides. 2y equals 24. Divide both sides by 2. And proposed, whoops, lost you. Sorry about that. Lost me, I should say. The proposed solution is the ordered pair 8, 12. That's what I think the answer is. However, of course, I'm going to check it in both of my original equations. So step 6, let's check it in the original equation. The original equation 1 is, let's go back up to here. The original equation 1, keep myself straight for your paper, is 3x plus 2y equals 48. So 3x plus 2y equals 48. I think the answer is 8, 12. X equals 8, y equals 12. So I'm going to substitute. And I'm going to check it. So this at the moment is a question. Is that true? I do my math. I get 24 plus 24. Does that equal 48? Well, that does equal 48, as you know. And so I have checked, and my proposed solution works for equation number 1. It needs to work for both equations in order to be the solution to the system. So equation number 2, I'll go back up here. Equation number 2 is 9x minus 8y equals negative 24. So go back down. I'll write that down. 9x minus 8y equals negative 24. My proposed solution is x equals 8, y equals 12. So 9 times 8 minus 8 times, 12. Does that equal negative 24? Well, this is 72 minus, I think that's 96. Does that equal negative 24? And the answer is it does. Okay, so my proposed solution is my solution. It worked in both. So I'll write down here, solution is the ordered pair 8, 12. So there you have it. That's an example of the solving a linear system by addition. Let's do one more with a slight wrinkle in it. I gotta find the paper. Oh, on the back. Silly me, right here. Okay, slight wrinkle in this one. Okay, I think I've got myself zoomed in, focused. Solve using the addition method. And you'll notice in this one, I am not in the general or the standard form. This is 2x equals 7y minus 17. And this is 5y is equal to 17 minus 3x. So we need to do step 1 here. And I'm not going to list the steps out again. I'm not going to write step 1 or step 2. We're just going to go through it. You can make note of those if you need to. So we first need to say, okay, let's write this in the general or standard form. So I need to subtract 7y's from both sides. And that is equation number 1 in the general or the standard form. I need to add 3x's to both sides. And that's equation number 2 in the general or standard form. Okay, you'll notice here, there's no way to multiply one of the equations to get the opposite in the other equation. So I'm going to need to multiply, in this case, both equations to find a 0. Okay, I'm going to choose the following. I'm going to look at these two. Their lowest common multiple is 6. So I'm going to multiply the numerator by positive 3. Excuse me, the numerator, listen to me. I'm going to multiply equation 1 by positive 3 and equation 2 by negative 2. That will get me opposite coefficients, which I know the sum of which is 0. So the numerator, I'm getting caught up on numerator. So the top equation times positive 3 is 6x minus 21y is equal to negative 51. The bottom equation by negative 2 is negative 6x. And again, that was the goal. I want the opposite coefficients so that when I add them, it's a 0. Negative 2 times 3x is negative 6x. Negative 2 times 5y is negative 10y. And negative 2 times positive 17 is negative 34. Okay, so there's step 2. I had to multiply, in this case, both equations by a number in order to get opposite coefficients for one of the variables. Step 3, let's add them up. Well, that, of course, is a 0. And I have a negative 31y is equal to a negative 85. And yuck. Step 4 is solve. Let's divide both sides by negative 31. And y is equal to 85 over 31. I said yuck because I got an improper fraction. It's not a nice, neat number. That's okay. We can deal with improper fractions. It doesn't bother us with our calculators. So there's that one. Step 5, let's back substitute into one of the two originals. So I'm going to choose the first one. I'll choose equation 1. Equation 1 says 2x. And I'm going to replace y with 85 31st equals 7 times 85 31st minus 17. Do some math on this one. This is 2x is equal to 595 over 31 minus 17. Oh my goodness, that's a mess. Let's see here. I think this is 2x is equal to, if I put them to a calculator, I get 68 over 31. And finally, I'll divide both sides by 2 or multiply both sides by 1/2 and then simplify if necessary. And I have 34 over 31. So there's my proposed solution is not a pretty one. The x value is 34 over 31, and the y coordinate is 85 over 31. Oh my goodness. And then I need to check that, of course. I will let you do that. You've got a calculator, and you can go back into here and put 34 over 31 in for x, put 85 over 31 in for y. Use your calculator to see that both sides are, so that both equations are true. And you'll find, once you check, that the solution set is indeed 34 over 31 and 85 over 31, and this, of course, is after the check. Okay, so I'll let you do that as well. So the key to addition, you want the key to the addition method is you want to have the coefficients of one of the variables be opposites so that when you add, they zero out and you're left with one equation and one unknown, which is easy to solve.